back into viewController.m, what more is happening here? This line of code, add subview. We've not done this before, but we've kind of felt the results of a line of code like this before. Thus far, when we've dragged and dropped things like buttons and text fields and sliders from that little menu and interface builder and dropped it, we've been adding a view on top of another. In other words, adding a subview. This is the corresponding line of code to dragging and dropping in that interface. I'm taking my paddle and laying it on top of the game board itself, which is just that big black rectangle by default. OK, so now turns out making this super simple and kind of pointless game is as simple as implementing the touches moved method. So the touches moved method is a little different from the pan gesture recognizer that we implemented earlier. Touches moved actually allows you to detect all sorts of touches on the screen, multiple fingers, touches in different locations. And it turns out this actually makes it even easier to respond to those key presses, though we could have done this in different ways. So touches moved is going to be fired anytime a UI view is touched on the screen. And what's going to happen here is this. When this method touchesMoved is called, actually the method is called touchesMoved with event, I first ask the event that I've been passed as my second argument, give me all of the touches, and then give me any object. This essentially gives me, in this case, the only object that could have been touched. If there had been a whole lot of things on top of one another, it's possible that multiple things would have been touched because of the various, the z-axis, so to speak. But in this case, there's only one paddle on the screen, so I only care to get whatever's in that set, so any object will do. I then, with this line of code, ask it for its location. What are its xy coordinates, essentially? And I store those in something called a CG point. A CG point is just a tuple, x comma y. So where on the screen was that finger touch? Now, what do I want to do? So I don't care where the user's finger is along the x-axis. I only care where it is on the y-axis. So I don't care if the user goes up, down over here or goes up, down over here. He or she is only going to be able to move the paddle along some fixed axis. So which value, .x or .y, is of interest to me here? The location .y. So if I want to center the paddle, notice what I'm doing here. It turns out that center is a property associated with the paddle view, or more generally, any UI view has a center. And I need to assign it an x comma y coordinate. I'm actually not going to bother. I'm actually going to change its y location, but I'm not going to change its x location, because I don't want the paddle to start moving along the x-axis in this landscape mode. I only want to update the y-axis. But I need to assign its center an x comma y coordinate, so I have to actually give it a point, and CG point make gives me that tuple, gives me an xy pair. So in the end, we get this very simple, kind of pointless game where the thing follows my mouse or my finger perfectly no matter where on the screen my mouse is without actually responding to the lateral movements. Yeah?
Can you constrain the touch and all touches to be inside of the object as well?
Absolutely. We could constrain the touch to only work, for instance, if actually touching the white box by actually looking at the x coordinate and the y coordinate and saying, are you within some certain bounds? If so, move. If not, ignore. Absolutely. And we can kind of change the functionality of this thing altogether if I instead change this line here from the same x that it currently is to location.x. What's going to happen if I now run this version? It should follow my finger, or in this case, the mouse pointer. So if we go to the simulator here, boot this up, and this is kind of a stupider game now. Well, actually, you might have an advantage now if playing Pong. So, all right, so what remains to be implemented? You saw Pong a moment ago, and you might have played Pong years ago. So we've got the beginnings of it. We've got the user's half of the game. What more do we need to do? Yeah? Yeah, so we need to implement some kind of little white ball that's going to bounce back and forth. In fact, the bouncing sounds kind of interesting, because if it hits the top or the bottom, we need to do some kind of reflection, like on a pool table or like from geometry. So we have to think about that. What else has to be implemented? So the tally, so we have the big score at the top. So maybe that's a UI label. We could kind of cut some corners and not do everything in graphics. We could actually just use a font and actually update two labels for the left guy's score and the right guy's score. It's collision detection of what?
Between the ball and the user's paddles and also the ball and the
Yeah, exactly. In addition to the top walls from which we want some bouncing to happen, the end walls mean a point has to be scored. So we have to somehow detect if you've gone too far left or right with the ball. And we've got to detect if you've hit the left or the right paddle and that ball has made contact. So there's a lot more to think about, but these are all probably building blocks we can start to piece together. So let me go ahead and open a final form of this and see if we can pluck off it piece by piece and see what the origins of each trick are. So here is, I propose, a working solution. And even I kind of cut a corner here. Based on the files you see here, what corners have I cut thus far? Really just in the interest of simplifying things we've already looked at. Yeah?
You didn't make a specific class, view class for the ball.
Yeah, exactly. I have a Pong view, which, as we'll see, kind of manages the whole game. But I don't have a paddle view anymore, and I don't have a ball view, because I realized along the way that it'd actually be a lot easier to make a paddle in Photoshop and a ball in Photoshop and just import pings. And so I seem to have done exactly that. Paddle.ping and ball.ping are just going to be graphics. But that's not enough. I can't just plop pings on the screen. What object, what class do I have to wrap around these images, as we saw with Rob before? So a UI image view. So we're just using a different UI image view rather than making absolutely everything from scratch. So we'll start, as always, in the app delegates. Nothing going on there. AppDelegate.m, nothing new going on there. Other than, actually, this is one good thing to highlight. We've used the app delegate for terribly little, other than the built-in functionality. But what do I seem to be doing with this application will resign active? A bit out of context now, but take a guess. What does this mean, and what am I doing in response to it, do you think? How about the first question first? When does this method, application will resign active, likely get invoked?
When you get from the background.
When I what?
Get back from the background.
Close. Just the
Will resign.
will resign.
Will it go background?
Go ahead.
When you flip the phone.
So it's not actually orientation. It's instead when the app is backgrounded. So if I get a call and I take it, or if I push the home button and I resign active state. Remember when we made key and made the key an active window earlier? This is the same idea, the opposite of that. So what am I doing? I'm apparently passing a message called kickoff to self.viewController. And I only know this intelligently in hindsight. The first time I sat down to implement something like this, anytime I did get a call or anytime I backgrounded the application, then came back to the application, I immediately lost because I had no recollection of where the ball was. My brain wasn't quick enough to actually move tell my finger to move the paddle to catch the ball. So I realized, wait a minute. If the user has to effectively pause the game to take a call, respond to an SMS, background it, whatever, it'd be a nice courtesy to pause the game. So kickoff does effectively that. It just moves the ball back to the kickoff location. The idea being, I figured, let's just start from let's not reset the score. Let's just reset the ball's location to the middle, like you might have in a soccer or football game. All right, so that's the only difference there. PongView.h doesn't seem to have much going on here. PongView.m looks like this. Not too much, but a little of this low-level stuff. And I thought I'd draw something different. Let me open up the game again. And in the simulator, there was one other design element on the screen. Does anyone remember what? I think I heard? Yeah, the dashed line in the middle. So this is surprisingly non-trivial to do. And I didn't want to resort to Photoshop for everything, but I thought that kind of looked like a nice line down the middle, and we can draw this using core graphics on top of my canvas. So in this case, I first need to get something called a context. And the context you can kind of think of as like the canvas, the current context for your graphics. And now we have some sort of weird use of C, but in the end it's fairly straightforward. I'm first declaring a variable called dashes that's of what data type? It's of type CG float, but specifically It's an array of CG floats, whatever that is, Core Graphics float. So it's some representation of floating point values for this particular library. 1, 1 is essentially, as we're going to see, it's going to mean draw a little bit of white, then have blank space. White, blank, and that's how we get the sort of zipper effect up the screen. All right, so CG context set line dash. So this function is essentially saying, what's your canvas? Dashes is what pattern do you want to use? And 2 just means how big was that array. Next line here, CG set stroke color with color. What's your canvas? What color do you want me to draw in? So in this case, this is a bit of commingling of C and Objective-C. UI color is a class. White color is a convenience method or class method inside of that class that returns to you some Objective-C representation of the color white. .cg color converts that NS object, that UI color object to a C-style struct for the Core Graphics library. Down here, we set the line width to be fairly arbitrarily 5 points wide. We move to the point 240, 0, so we're essentially going to the middle of the screen if we assume 480 points total. Add line to point. This is saying go from where you are all the way up to the top, so sort of draw that dashed line. And then lastly, fill in the dots, so paint along the trail you've just left. So if you remember like a language like Logo years ago, the little turtle turning up, down, left, right, and drawing things or leaving a trail, it's the same kind of idea where you move a cursor around and you tell it when to put the marker down and draw, when to let go, and so forth. We've essentially drawn a dashed line in that way. And now the whole point was, again, to overlay on top of our view this Pong view. So here we have viewController.h. We're almost into the brains of the game. ViewController.h apparently declares one method called kickoff. Why did I put it in my .h file? I feel like I'm regressing to our previous techniques. Yeah?
Well, because you called it in a different class, which means you need the other class needs to know that there is a kickoff.
Exactly. In my in my appdelegate.h, recall that I appdelegate.m, recall that I called the kickoff method in this line here, and that's why I imported viewController.h, and that's why in viewController.h I'm actually declaring this method publicly, so to speak, in the .h file and not in some nameless category in the .m file. All right, so the nib file looks like this, and it's a little different this time in that I seem to have laid out in advance a few different widgets, so to speak. What appears to be on the screen here? So some text. So I conjecture this is a UI label. That's another UI label, and I just put some default text there, even though the human never sees it. What else is on the screen? Yeah. Yeah, so the image views. So let's take a look. If I first expand the hierarchy here, I can see what I've laid down on this canvas. And indeed, there's 3 image views, or UI image views, the class name, and 2 labels. And if I actually click on these things, we can see how they're configured. Let me click on the ball in the middle there. It's 10 pixels by 10 pixels, according to what I made in Photoshop. And it's indeed a UI image view whose image source has been specified to be that ping in question, just like we did with the rob.ping earlier. Same deal for the others, and score left and score right, if we go to the identity inspector, is indeed a UI label. So in this case, what I literally did in advance was I dragged and dropped 3 UI image views from the palette of options down there. Then I configured them, just like we did with Rob earlier, to be ball.ping or paddle.ping, so as to lay that out. And then the scores, I just manually typed. Previously, they just said label, and they could still say label. I just thought it was a little more instructive to give them left and right names. That's all. All right, so now if we go to viewController.m, here's where all the interesting stuff must be happening. So first, I decided, just to make it easy to tinker with my game, to declare a velocity constant at the top of the file, initialized to 10.0 in a floating point value. So this is like the speed, 10 points per second or some unit of time. And then I have inside of my nameless category a CG point velocity. So somewhere in this class, I need to keep track of what is my current velocity. Because a velocity, recall, is essentially a vector telling me how fast to go straight up, or to the right, or the opposite thereof. So it's some kind of speed, a change in rate, dy dx. So I need to store my current one so I know at every second of the game, how fast should the ball be moving. Now, I have a whole bunch of private properties here, but most of them are as expected. I've got IB outlets for all 3 of the UI image views that we saw earlier. And I've got 2 IB outlets for the UI labels that we dragged and dropped. So that leaves a few here. NSU integer, what might that mean? Yeah, so it's an unsigned integer. Why? I figured the score never needs to go negative. So just to be proper, I'm going to specify that it's an unsigned, that is non-zero integer. I could have just done little u